morning, Dragons, and welcome to one of your Day 3 videos. I already posted another one for the interactive notebook called Introduction to Ratios, so hopefully you got to see that either last night or early this morning. Now I'm going to actually walk through the problems because they did a bunch of EOG-style problems, both calculator active and inactive. I'm going to try to do them without the calculator and then check them with the calculator. That's my plan right now. Got a couple pens, my trusty whiteout. And I'm going to get started with you going over these problems because we haven't seen ratios in quite a while. Now, it appears that DPS gives you a video resource each day. I have not clicked on these links. I do not know how thorough they are or how long they are, but feel free to use their video resource. Showing equivalent ratios. Read the problem below, then explore different ways to show equivalent ratios. A cafeteria worker knows that it takes 3 bottles of juice to serve a table of 18 students. How many bottles of juice are needed for 24 students? How many bottles of juice are needed for 42 students? Picture it. You can draw a diagram to represent a ratio of 18 students to 3 bottles of juice. Alright, we got 6 happy faces to 1 bottle of juice, and it's repeated 3 times. So that would be 18 students to 3 juices. 18 students 3 juices. All right, so there we have colon notation. We could also do word form or fractional form. Remember, there are 3 forms in which to write ratios. Model it. You can also make a table to show ratios of the number of students to the number of bottle of juices. So, I don't know if you remember, but this is like the unit ratio here, because 1 bottle. It is 2 different things, so you could call it unit rate. The bottom one is skip counting by 1. The top one is skip counting by, what do you see there, what pattern? If you said 6, that is what I'm seeing. You could also scale up and down, like 1 times 4, then you would do 6 times 4. 1 times 5, so I would do 6 times 5. 1 times 6, then I do 6 times 6. 1 times 7, that's how I'm traveling there, so I do 6 times 7. The table illustrates all the equivalent ratios for the different bottles of juice associated with how many number of students. Let's jump into the problems. Calculator inactive. The distances and times of practice runs for 4 students on the cross-country team are shown in the table below. Which runner has the fastest pace in minutes per mile during these practice runs? Minutes per mile. Okay, I'm going to take care of each individual. We got Sean, who is 21 minutes to 3 miles, and that would, I'm going to scale him down to 1 mile. So if I divide by 3, he is 7 minutes in a mile. I've got Gwen, who does 32 minutes for 4 miles. Scale that down to 1 mile. Divide by 4. Divide by 4, that looks like 8 minutes per mile. Let's see, running out of room a little bit. We got Mark. "30 minutes for 5 miles. Scale it down to 1 mile. Divide by 5. Divide by 5. That'll be 6 minutes per mile. That's not bad. And then Amani. Let's squeeze that in here. We got 14 minutes for 2 miles, which scales down to 7 minutes per 1 mile. Alright, looks like Mark is our fastest? I'm going with C. Mark is our fastest. We can run a mile in 6 minutes. Number 2. Hannah's antivirus program scans 160 megabytes of data in 4 seconds. At what rate in megabytes per second does the antivirus program scan the data? 160 megabytes in 4 seconds is equivalent to divide by 4, scaling down, divide by 4, scaling down. I want to say 40 megabytes per second. I'm going with D. A youth ice hockey game has 3 20-minute periods, so that's a total of 60 minutes. Colin plays 12 minutes each period. Each period, let's see, 12 times 3 would be 36. He plays a total of 36 minutes. Which ratio represents Colin's playing time to the total number of minutes of playing time possible? So we've got to do Colin to total. So Colin plays 36. The total is 60. We have to scale that down. Right off the bat, I can see that 6 will go into both of these. And I don't even think that's the greatest common factor. Greatest common factor is probably 12. Divide by 12, that would be 5. Divide by 12, that would be 3. 3 to 5. If you had divided by 6, you would have gotten 6/10, which would reduce to 3/5 anyway. 3 to 5. B. If your answer is a mixed number, change it to an improper fraction or decimal. Mixed numbers will not be accepted in the gridded answer sheet. Desiree ran 12 miles in 1 hour 48 minutes. What was Desiree's average running rate in minutes per mile? Well, right off the bat, we got to convert those hours to minutes. So that would be 60 minutes plus her 48 minutes is 108 minutes. He wants minutes per mile. So 108 minutes to do 12 miles. How long to do 1 mile? I cannot remember off the top of my head if 12 can go into 108 evenly. I'm thinking 6. That might work. Yep. Let's see. Goes in 9 times. So Desiree can run a mile in 9 minutes. So minutes per mile, 9. Yeah. Same idea here, gridded response. Malcolm's smoothie recipe uses the ratio of fruit to yogurt that is shown in the table below. Fruit to yogurt. What scale factor is applied to the number of cups of fruit to get to the number of ounces of yogurt? I want to say 4. To get from fruit to yogurt. Is times 4. Times 4. Times 4. Times 4. Going with 4. What is 80% of 82? Well, 10% of 82 is 8.2. Times 8. Times 8. Let's see, let's do 8.2 times 8 over here on the side. There we go. I love when it's one of the answer choices. Okay, let's check that one. That one says calculator active. So, let me get the light on that for you. We've got 80% of 82. 0.8 times 82. Correct. Yay. Vincent burns 30 calories walking for 10 minutes. At this rate, how many calories will he burn in 15 minutes? Alright, so he goes 30 calories in 10 minutes. We could scale that down first. Divide by 2, we could get 15 calories in 5 minutes. We could scale it up to 15 minutes. I'm going to do times 3 here, times 3 here, which would be 45 calories in 15 minutes. So here I divided by 2, divided by 2. Why did I do that? Because 10 wasn't friendly with 15, so I went down to 5 because 5 is friendly with both of them. Once I cut it in half, I could scale up easily by multiplying by 3, both top and bottom, and I got to 45 calories. You could have scaled all the way down to the unit rate, too. Alright, the graph shows the amount of money that is collected for a school play based on the number of tickets that are sold. Nice, okay. Number of tickets, amount, I get it. Kind of has a 1 to 4 ratio. Which other coordinate pair also represents the relationship between the number of tickets that are sold to the play and the amount of money that would be collected? Alright, remember it's always x comma y, so 200 to 50. Well, that's like here. 250 to 550. That's like here. 300 to 1200. That has potential. 450 to 1600. So they're asking here which one falls on the line. Just making sure I got this one lined up correctly. Well, for this one, I really want to take a straight edge. That is my first instinct. I don't have a ruler with me, so I'm going to take the side of my stapler. I'm going to go through the origin, assuming that it's a proportional relationship. I'm going to connect the first 2 dots that are provided to me. So my goal there was to connect these 2. And the line would go on forever in quadrant 1. And I'm wanting to see which other dot fell on my line. It's this guy. So 300, 1200 is your solution. That one also falls on the line and is proportional to the others. Another way you could have handled this is you could have taken 100 over 400, scaled it down, and then tried to scale it up to be equivalent with one of these. You could have chosen not to use the graph and crunched the numbers only. That is an alternate way to solve this problem. Number 9. On Saturday, 40% of the visitors to an art museum were students. If 140 students visited the museum that day, what was the total number of visitors that day? Alright, that's another percent problem. And I don't know if you remember, but it's part over whole equals percent over 100. So they're saying 140 students is 40% of how much we don't know. I'm going to scale down because 40 and 140 are not compatible. But if I divide by 4, I can get down to 10/25. Then I can scale up, multiplying by 14. 25 times 14. I know this one's calculator active, but I did tell you I would do it without the calculator first. Alright, according to my calculations, the entire amount should be 350. The way I actually check these might surprise you. I go, what is 40... Sorry, the lighting is imperfect here. What is 40% of my total? And I hope to get 140 students. And I did. So I work backwards a little bit. I test my total. B. I am satisfied with that answer. moving on. Okay, we're doing pretty good. 2 more pages. Well, this is just one giant problem. Let's take a look at this. A football team holds a car wash as a fundraiser. The team makes the graph to see how much money they could raise from washing cars. All right, they've got a nice straight line that would fall through the origin, so this appears to be a proportional relationship. 5 over 25, 1/5. Which table models the data in the graph? This feels like a matching game. I feel like it's A, but I'm going to check the others, just in case. Number of cars washed is the x coordinate. So that would be like x. And this should be x. And this should be x. And this should be x. The first x is 5. If you look at the first graph, or the first point rather, you go over to 5. If it doesn't say 5 in the first one, you can cross off that graph. This one is saying x is 25. X is not 25. So it can't be this graph, and it can't be this graph. Now you're down to these 2 graphs. The next one is 10, 50. 10, 50, good. 10, 30, not good. Your answer is A. So you're just matching the ordered pairs to the correct table. This first ordered pair was 525. This ordered pair was 10 and 50. This ordered pair was 15 and 75. This ordered pair is 25 and 125. And this ordered pair is 30 and 150. Then I'm just going to verify. I'm just going to match 5 and 25, 10 and 50, 15 and 75, 25, 125, 30 and 150. Okay, so I verified that all the ordered pairs, in fact, match my table. Didn't even need a calculator for that one. Mrs. McCrae is ordering new textbooks for her math class. The table shows the relationship between the number of textbooks and the total weight of the textbooks in pounds. What is the ratio of textbooks to total weight? I always check to make sure we do it in the right order. Textbooks to total weight. It is not a friendly ratio. Now we might want our calculator. I'm going to divide this and see what I get since I'm allowed to use my calculator anyway. I'm not enjoying this number right now. That is crazy. They want textbooks to total weight. Let's see. Sometimes I like to test where they're trying to go with this. But if I scale down this number to 1, like if I were to test it, just for example, and I wanted that bottom number to be 1 to match that example, I'd have to divide this by 17.5, which means I'd have to divide 5 by 17.5, which is 0.28. That's not a match. Or if I test it in the way that they want me to test it, and I make 1 the top number, I'd have to divide by 5, which means I'd have to take 17.5 and divide by 5. So I'm going to take 17.5, divide by 5, and I'd get 3.5. So far, I'm unable to match them, so I'm going to keep trying. I'm working backwards on this one, mostly because the numbers are super unfriendly. They're saying make the top number 2. So 5 divided by what gets you 2? 5 divided by 2.5 should get you 2. 5 divided by 2.5 gets you 2. So let's do 17.5 divided by 2.5. You get 7. Okay, so that is a viable match. I'm going to try the last one, but I suspect it won't work because right now, since this one was a match, this one doesn't make sense. So now, if they want me to get to 2 here, yuck, or even 7, if this is not going to work. Because 7 divided by 5 would be 1.4. So 5 times 1.4 equals 7. But I assure you that 17.5 times 1.4 is not equal to 2. It's not. It's equal to 24.5. So that is not a viable match either. It has to be this one. Has to be. 2 sevens. 2 to 7. Textbooks to weight in pounds. I'm curious if this has the same ratio. So I'm just going to divide it really quick. How do I test if it's the same ratio? If I divide this guy by this guy, I should get the same amount as if I divided this guy by this guy. So 5 divided by 17.5 is basically 0.29. 0.29, if I round it. 12 divided by 42 is basically 0.29. And then 28 divided by 98 is basically 0.29. Okay. So, I just wanted to verify that the ratios within the table, in fact, were equivalent, and they are when I convert them to a decimal. And then I tested each one because the numbers were really unfriendly, and I didn't want to make a mistake. So, after we tested each one, we could see that the only reasonable choice was C. Next. An art student is mixing blue paint with yellow paint. I love these. To create a custom color. I imagined it would be a green. The table below shows the amounts of blue and yellow paint that are mixed together. What number is missing from the table? Let's see. What is that? Times 1.5, times 1.5, times 1.5. They're skip counting too. Plus 6, not plus 6. Plus 12. There would be something, there should be another row right here. But we can do a scale from here to here. 6 divided by 1.5 would get you 4. I'll prove that. 6 divided by 1.5 would get you 4. Which means I need to do 30 divided by 1.5 to get a solution. Is calculator active? 30 divided by 1.5 is 20. 20 is here. And just to check it by hand, 30 divided by 1.5. I wonder if you remember how to do this. You got to move the decimal over. If you do that, you got to move it here too. Make it rise up. 15 goes into 32 times. 2 times 15 is 30. Subtract, bring down, repeat. Boom. 20. Alright, I'm hoping we're done. Yay, we're done. Okay. I'll also post the answer key online for you on the Dragon website. And that should do it for day 3. Time permitting, I'll put another interactive notebook page on, but I do have several meetings today, so I'm going to see how it goes. But I definitely want you to get these practice problems finished. They were excellent practice problems. Thank you for watching. I'll see you soon.